We are now going to move from one type of bird to another type of bird, a kingfisher, and explicit space management. And Justin, take it away.
All right. Hello, everyone, again. So I was lying in bed Wednesday afternoon after having finished the HTC25 Hell Ramen Spicy Food Challenge. Miserable, wondering where did I go wrong in life? And I won't venture a guess as to where I went wrong in life, but I had a great idea. So like all great thinkers, I asked someone else to do the work and went to ChatGPT to exercise some vibe coding, right? So here's my great idea. I decided it was time for something new. Condor reached its 40th birthday, but we can do better. So I introduced a revolutionary new scheduler that is going to render Condor obsolete. I can say with complete confidence that Condor has carted off the last of its computational carrion because this revolutionary new scheduler does away with all of that bloat that we really don't need. Things like fair share, we'll just get rid of it. Priorities, quotas, resources, all of that, we don't need it. No more job accounting, matchmaking, class ads, none of that extra overhead that we can just exactly chuck it. Just pure, raw opportunity. So, how did I do this? Well, it was pretty simple, and I'm honestly surprised Marone didn't think of it first. Need a CPU? Just go find the closest one you see. That easy. Someone else was using it? Even easier. Kick them off the system. Worried about your own jobs running to completion? Ladies and gentlemen, introducing Dodo. Finally, a grid scheduler providing super high throughput for researchers with many, many jobs. Minimize your latency, maximize your hertz. This is about where I pause and watch Marone in case I need to dodge any heavy flying objects. Okay, so I hope everyone here is picking up on the satire here, right? This is a terrible idea, and we know how it ends up for this bird. The only thing you're going to maximize is the pain and suffering that this would bring. But in Condor, we've spent decades engineering careful and explicit resource management into the way we do things. And here's the punchline. In the OSDF, we kind of do all of these bad ideas, right? We don't really have any concepts of fair share, and you can argue, what does fair share mean? Is it a namespace? Is it a user? But we don't really do anything, right? We still also kind of just grab the closest cache we see, and if I suddenly start pulling a petabyte through it, that's going to have impact on the other people who had their data stored in that cache. We also don't really have a good way to control data lifetime. We have accounting, but it's in the logs, right? Not really a great extensible way to peer into what's happening in these caches. So the effect of this is that one user, one ambitious user, is able to really degrade the experience of the whole thing for the rest of the Federation. So we woke up on Monday to some pretty red OSDF dashboards, and we started digging around. What's going on? What's breaking down? Where is the fire? Where is the smoke? And then we saw this pop up in Slack from one of our dear friends at LEGO, who had an ambitious user, a scientific endeavorer, who decided they were going to launch a DAG with nearly 500,000 different jobs. And so I can say with assurance that truly none of us can escape the gravitational pull of a black hole merger. It affects us all. So the question is what if we thought about scheduling storage the way that Condor schedules all of its other resources? And that's the idea that we're trying to explore in Kingfisher. So we love our birds. We decided we were going to name this NSF element after another bird. And I want to start with some plain English ideas of the types of things that someone might ask us about with regard to scheduling storage. So the first example is, I have a terabyte of disk, and I want to share it with people. I maybe own the resource, but I want to delegate it to other people so that they can also use that resource. Or maybe I need 500 gigabytes of disk, and I need it for about 24 hours because that's how long I expect my science will take. And but if you had more disk available, if there were an extra 100 gigabytes, I'd benefit from that. I don't need it, but it would be useful. Or finally, my cache is full, and I want a convenient and so-called fair way to manage cleaning it up. So lurking in all of these should be a familiar problem that everyone in this room has hopefully thought about. And that is the idea that there is somebody who owns a resource, and there is somebody who doesn't have a resource but would benefit from using it. And we can talk about the different ideas of how these two express their policies and how they find each other and negotiate some kind of a contract. I'm not going to talk at all about that kind of matchmaking. Instead, I'm going to focus first on the expression of those contracts. So I, as the person owning a resource, how do I say what I'm okay with other people doing? Or I, as the person who want to use that resource, what kinds of things can you make available to me? How can I better utilize it or share it with other people once I've been given an allocation? So Lotman is a part of the Kingfisher project, and Lotman is a library or a framework for thinking about some of these problems. So we want to think about, there's a resource and someone owns that disk, but someone else might own the bytes, the things that we stick on that disk. And how do we reason over these two different notions of ownership? Or if I've been given an allocation and you share your disk with me, how can I, as the person who is borrowing this space, subdivide it and share it with other people, maybe in my lab? And then finally, when we do come back to that idea of scheduling and matchmaking, what kinds of language do we need to consider in order to think about it? So, like I said, Lotman is a library written in C++, introduces a set of semantics for reasoning over these different types of questions. And to do this, Lotman creates this lot object, right? The lot object is the kind of primitive in Lotman that we're going to think about. So what is a lot? Well, we start off with some kind of abstract storage here. I didn't make it a disk because let's just think of it as a bin that can hold some stuff. And I'm going to throw this fluffy cloud into it. And this cloud is going to represent a lot. So what is a lot? Well, to start, lots have a name. We need a way to reference it. We want to give it a name so that we can talk about it. And that's an important piece. Lots also have an owner. Now, what do I mean by owner? Because we've talked about the difference between the person that owns the storage resource and maybe the person who owns the stuff stored in that resource. In this case, owner means the person that owns the stuff in the lot. It's the data owner, the person who put the files there and has some responsibility over managing those files. Next, lots are tied to a specific slice of storage. So we might say that a lot contains the paths foo, or everything under the path bar, or some object in OSDF, or some portion of a namespace. It's a way of attributing something that could be in the storage with the lot that is responsible for kind of keeping track of that information. Lots also have these other things. Maybe I picked a bad name for this. I call them management policy attributes. They're the types of things that help us reason over things like quotas. So a lot is given some dedicated storage, some opportunistic storage. It's given a lifetime, a creation, an expiration, a deletion. And you can kind of think about these as like I said, quotas, but they're also a way of expressing kind of hard versus soft quotas. So I might say, I promise you at least 10 gigabytes, but I'll give you some opportunistic storage. And if that extra storage is available, I'll let you use it. That's the opportunistic piece. Next, lots are hierarchical. So I decided when I was trying to figure out how to best represent this pictorially, that it was really important that this sublot here was not nested inside of this other lot. And the reason I made that choice was because this sublot does not necessarily contain some other stuff that's in this lot. It may not contain objects or files under this foo path. It may not contain bar. Rather, this hierarchical relationship between parent and child has more to do with the quota management, so these management policy attributes. And by that I mean that if Patrick's lot is given 10 gigabytes of dedicated storage, and Justin's lot is given 15 gigabytes, if all of a sudden Patrick comes and stuffs his lot with 10 gigabytes of stuff, that counts toward the parent lot's dedicated storage quota. So it's hierarchical in these management policy attributes. And then I think a really important thing to take away from this is that Lotman itself is advisory. It's a way of accounting. It's a way to help manage this bookkeeping. And so it's never going to make decisions for you. If you fill up a lot and you blow past all these quotas, Lotman's not there to clean anything up or manage the space for you. Instead, it's keeping an eye. It's counting statistics. It's counting how many things you put in, how big they are. And it provides a kind of query system so that you can ask for lots that meet certain policy criteria, right? So I might say, dear lotman, tell me about all the lots that have exceeded their opportunistic storage quota. And it'll tell you the names of the lots and their associated storage that satisfy that criteria. So lotman doesn't do any of the disk management. It helps you reason about the disk management. Okay, so going back to some of those plain English examples from before, how does lotman help? So I am allocated a terabyte of disk, and I'd like to share it with my lab members. This is a case where we might create one lot to represent that whole allocation, and then we might carve it up into 5 different sublots. So combining the hierarchical ownership aspect and that dedicated storage quota lets us subdivide and delegate that resource. This next example, I need 500 gigabytes of disk, and I need it for 24 hours, but I'd benefit from more space if it were available. So we'll create a lot, we'll give it a 500 gigabyte dedicated storage quota, and we'll give it some extra opportunistic storage so that if that extra space is available, we let the person who owns this lot fill it up with their stuff. But if I need to take that back at some point, we have a way of understanding how we might do that. Finally, my cache is full. I want to reclaim space, but I want to make some decision about the way I do that. So in this case, we might say that we will clean data in accordance to some ordering of lot policies. Maybe we start by saying, I'll clean all the lots that are past their expiration or deletion timestamps. Then I'll go to the lots that are using more than their dedicated storage quota, and so on and so forth. So you can think about how you might construct policies that provide an ordering of what to delete. Okay, so the OSDF provides a really convenient playground for thinking about some of these concepts, for playing around with these ideas, not necessarily because at this stage we're saying we know how to do it better, but we want to explore and see how they work. So before we think about writing a policy and saying this is the way we're going to manage disk on these caches, what can we observe? What do we want to accomplish? First, we want to protect ourselves from those black holes. We want to make sure that if one user has some ambitious amount of science, or they come and they decide to slurp down a petabyte of stuff through this cache in a couple hours, how can we make sure that that doesn't degrade the experience for everybody else? Next, and this is a very general statement, right? Hit rates in caches are typically higher if the cache holds more stuff. You know, maybe if we could predict what is going to be in the cache and certain patterns about object reuse, we could do an even better job. But barring any of that kind of prediction, because as we talked about, prediction's hard, in general, hit rates are higher if the cache holds more stuff. So we want to find a way to keep that cache full. But at some point, we're going to have to make a decision about what do we delete? What do we clean out of this cache to make room for the next petabyte of data that shows up? So we want to make informed choices about how to do that. We also need a way, and this is an interesting question, to pre-allocate space for upcoming workflows. So if I know that tomorrow I'm going to be running a job that needs 100 gigabytes of disk, what can I do to make that disk available ahead of time, to schedule it, so that I can put my data there and have it ready and available when my workflow matches with an execution point? And I'm going to gray this one out because we'll come back to it at the end, and I just want to plant that brain worm and keep it buffered in your memory. Okay, so what do we do to address these particular cache-related problems? We want to protect ourselves from black holes. So according to some policy, we'll take the cache's total disk and we'll divide it up and allocate some amount of storage for lots that are tied to the namespaces, right? There's that question of who is the logical owner? Is it the person that owns the data? Is it the namespace? And that's kind of like an owner in the scope of the federation itself. We're starting to look at this by dividing the disk up by namespace and giving each one some amount of storage according to some policy. Next, hit rates are higher typically when caches hold more stuff. So we'll leverage Lotman's ability to reason over dedicated and opportunistic storage so that we can set quotas and allow caches to fill things up. And if there's more space, they can keep going and keep going. But at some point, if we need to clean it up, maybe we start by cleaning those lots first. And finally, when needed, when it comes time to delete things from the cache, how do we decide which of these namespaces and the objects they hold are we going to target first? So we can create different policies, like I said earlier. We might say, we'll delete all of the lots that are past their deletion or expiration times. Then we'll go to the lots that are past some of these other quota primitives, and that gives us an ordering for how to clean things up. And I'll note that in the way we're thinking about setting this up, we're always guaranteed that we can get to where we want to go as far as cleaning because of the way we divide the namespaces into the storage. So we make sure that we never over allocate the storage. If you add up all of the dedicated quotas, it equals the size of the disk. Okay, so how do we do this in practice? This has all been kind of the plain English, but what does it look like if I start breaking out the block diagrams? So hopefully this is somewhat familiar to everyone who knows a little bit about Pelican, but we have a director up here, and this is our cache. It has kind of two processes. There's a Pelican process that's running. It's responsible for starting and kind of keeping an eye on this XRootD process. And sitting between the two is the Lotman library that points to some database. There's also this purge plugin. We'll talk about that in a second. So Pelican wakes up at the cache, and it decides, I need to discover something about the namespaces that I may be expected to work with. So if you understand Pelican architecture, you know this is a question for the director. We go to the director, we ask it about the namespaces, and we keep track of that information. There's also some local configuration, a high watermark and a low watermark. So the idea is, we fill and fill and fill the cache until we hit this high watermark, and then we're going to clean stuff up until we hit this low watermark. And that's kind of our benchmark for when to clean and how much we need to delete. There may also be some local policy that the cache administrator sets saying, for the namespace foo, I want to set aside a specific amount of storage or specific quota like that. So there's a merge operation that happens between any policy we might have as a default and what the cache administrator decides. And then there's this piece that tells Lotman what order do I consider cleaning things up in. So past expiration, past opportunistic, etc. Pelican uses the Lotman library to stick this in the database. It initializes the lots. And then XRootD is in charge of keeping all of the statistics up to date. So as XRootD receives object requests and it starts filling up the disk, it's going to tell Lotman about what it's putting in there, which space of storage those bytes are attributed to, etc. Now, at some point, we're going to hit that high watermark and we're going to exceed it. That'll trigger a purge routine in the cache that says it's time to clean up space. So XRootD goes to Lotman and it says, Dear Lotman, I have some policy, some ordering for the types of lots I want to clear. Please tell me which lots I should start clearing first and what storage I actually need to delete that's tied to those lots. So we might see first we might wind up deleting this larger lot at the bottom, but our disk is still not quite as empty as we want it to be, so we need to do a little more. And then maybe we go to the next type of lot that we're going to clean up. And at some point, we're going to hit a point where we've gone below this low watermark. So we know then that it's time to stop. So this is kind of generally how we're thinking about doing this in OSDF caches using Lotman. Now, there's still some work to be done. The first thing is, okay, this is great. This sounds cool. We haven't turned it on. We don't actually know if it works. Lotman was one of the very first things I worked on 2 years ago when I started at Mortgage, and it still has never seen production. So first thing is turn it on, make sure it's stable, make sure that the database accounting and all of that, the transactions can actually keep up with high throughput computing. I think we're pretty close to this in the next 2 to 3 months maybe. Next, we need to do a little more to handle automatic policy distribution. So if I, as a federation administrator, want to say something about, in general, how should the caches in my federation handle these kinds of policy decisions, we need to figure out how to propagate that policy and how to set good defaults and all of this kind of stuff so that it isn't just up to the cache administrator to come up with their own and maybe not make the right choice. We also need, and this was that bullet point I grayed out earlier, a good way to think about pre-allocating space. And this is especially important, right? Because we want to manage our resources explicitly. If you are submitting a job with Condor, you should have a sense, an understanding of how much space your stuff is going to take, right? You request a specific amount of disk because you expect that to be the resident size of your input sandbox when the job starts. And if we want to make that stuff available through OSDF, we need a way to make sure it's going to be sitting in the cache, pinned, and ready for you to use. So to do this, we're thinking, well, Lotman provides a set of APIs. You can send a token that tells a particular cache, hey, I am authorized to subdivide or manage or delegate these lots on behalf of some namespace. So I want to create a sublot for myself because I'm going to put something in there tomorrow. Please do that for me. So that's kind of the idea there. All right, so that's Lotman Kingfisher in a nutshell. Happy to answer.
And Dodo.
And Dodo, yeah, coming soon. So yeah, thank you, everybody.
All right, that was great. Questions for Justin? Go ahead, Kurt.
Is it on? Yeah. I guess picking up on the last thing, I'm kind of curious about the coupling between execution points. If I'm a user and I have an upcoming workflow, I don't know where my jobs are going to run. How do I know which cache? So essentially, how do you solve that problem for me, the user?
Yeah,
I don't want to have to know all that.
I think part of my answer is that I'm see if I can get back to the slide. You know, I talked a little bit about the matchmaking aspect, right? Two sides have expressed a policy. Something needs to find those two and choose, you know, to say that they are a good fit for one another. And I think that's the question of cache selection and multiple jobs needing the same input set of data. This doesn't really address that part. So I'm at this stage not yet considering how do we fix that, because we don't even have a good way to express what those policies are yet. So an important question, but not one that I'm yet actively working on.
So you mentioned the first set of policies you want to turn on, the OSDF. You know, how are you planning to measure it? Right?
Yeah.
So you turn it on. I'll believe you when you say it didn't crash.
Sure.
I can check to see if it did crash or not. How do you decide? How are you planning to decide whether it implemented the policy correctly or it was just a random number generator?
Yeah. So this is a good question. I'm gonna use one of Marone's favorite sayings. We'll get there on the back of a donkey. And by that I mean that I think a good first place, a good objective function to think about this is general stability in the OSDF. We care a lot more about did it work, did it give you the things you asked for, rather than how quickly were we able to move this byte into your cache and into your workflow. That's a secondary thing. If we can get the stability, and that's something we can monitor with these OSDF reports that we wake up to every morning, if we can see that the number of jobs that are interrupted because of OSDF has a noticeable and measurable trend downward after we turn this on, I think that's a good first place to start. Beyond that, I haven't thought too much about how to answer concretely which statistics we need to be tracking to say with confidence that this solved something. And I don't know that we can ever say it truly solved anything.
So you reason in terms of space, but then you try to pair it with a cache. So in a cache, there is more than just space. A lot of what the cache provides, it's reuse. And you have not shown any concept that would include reuse. So yes, I want the space, but would be nice to have some kind of notion that says, well, I expect maybe once or twice accessed.
Yeah.
Or this will be accessed 1 million times.
Right.
So I want them to be treated differently. So is that something you maybe consider adding? I don't know what exactly the semantics should be, but seems important for caching.
This is an important question. So my understanding of what you're asking is the question of object reuse, or even, you know, if I have 1,000 jobs that are all going to make use of the same cache and pull stuff, how can we think about reasoning over how many I'm willing to let run at once or something like that, right? Yeah. Yeah. I'll say that I'm pretty sure PhD dissertations have been minted over these kinds of cache management questions. I think some of that gets more into the policy creation aspect. So maybe a good first starting point is trying to modify this to just introduce some notion of, can I keep track of the things I expect to? Yes, yes, yes. I think that's a great point, and definitely worth considering here. So, all right. Thank you, everyone.